Hello my friend, today I would like to establish a connection between two processes. We have King Kai process, that is the server, and we have Goku, which is the client, that is gonna send a specific message leveraging Unix signals, especially SIGUSR1 and SIGUSR2. Let's jump into the code. Okay, let's start by King Kai. So file kingkai.c. We start by the main function, so int main void, because we don't need command line arguments. And at the end, we do return exit success. Okay, I'm gonna also create an header file that I call talk.h. Like always, I put the guards. So if not defined, define talk.h. At the very end, I put ndif. All right, in this header, I will put the standard input output. I will include also a Unix standard, especially for the write system call. I will include, of course, signals. And for now, it's basically it. So in my King Kai, I will include talk.h. Of course, I also need to include the standard library for the exit success standard library. All right, let's go back. And now everything is fine. All right, while I'm doing the King Kai, I want also to do Goku.c. I include talk.h. And as well, I have int main. This time I need the inputs from the command line, so it's going to be int argument counter char start argument vector, like that. Why is that? Well, because the input is going to be Goku pid of Kai, King Kai, and the actual message. Okay, so we actually need command line arguments. Perfect. Okay, let's start by King Kai. First of all, we have to printf the PID value, the process ID of King Kai. So the King Kai PID is equal to %d. And the function is going to be getpid. Very simple. Getpid, as this prototype, is going to return me a PID type, which is basically a Darwin PID type in my macros. As you can see, in my implementation, it's an integer, 32 bits. Perfect. Indeed, that's why I'm using here %d. Okay, if I run King Kai, I get this output, right? With this specific PID. Every time the PID is going to change, of course, right? So the value of the PID is different depending on the specific instantiation. All right, I want my King Kai to keep listening, so I'm gonna do an endless loop. I'm gonna do while forever. What do? Well, you pause. Basically, if you read in the manual for this function, you will see that the pause function causes the calling thread to pause until a signal is received from either the kill function or an interval timer. So basically now, if I run my King Kai, you see that the process remains idle. It waits for a specific signal coming from whatever. Perfect. Now, my process is going to receive SIGUSR1 or SIGUSR2 from Goku, right? So I need to establish handlers, right? An handler for these signals. Especially, I want to say that if SIGUSR1, the bit is going to be 1. On the contrary, if SIGUSR2, the bit is going to be 0. Okay, so this is my protocol of communication. To do that, I'm gonna use the sigaction system call, which I can use including the signal.h. As you can see, the sigaction function needs a struct which is called as well sigaction, right? So we have a struct and a function with the same name. This is the sigaction struct that contains an union, as you can see here, a sigset, and an integer. So here we have a mask for blocking signals, and here we have the flags. I will explain while coding this madness, okay? The union has two function pointers. The first one is this, and the second one is this. Basically, having a union is very, very cool because I don't waste memory, essentially. And long story short, this is a pointer to function to our specific handler that can have this prototype or this prototype. I plan to use both of them in my code so we can understand better what is going on. So I want to create a wrapper function to keep it simple, okay? And the function is going to be signal, okay, with the uppercase. Why is that? Well, the thing is that there is already a library function, which is basically a simplified interface to the more general sigaction. So I will do this. I will have my signal. I will pass as an input the actual signals that I want to handle. In this case, are SIGUSR1. Then the handler function. So I will write handler, and I will leave it as a to-do. And here at the very top, I'm gonna create my handler function. The prototype of my function, as you saw, needs to have this specific signature, right? I want this specific signature here. So it takes an integer, siginfo type, and a void star. So void handler int signal, a pointer to a struct siginfo. This is very important. Type, so info. And then we have another pointer, void star, a generic pointer to more info. These I don't need. Okay, this is my prototype. So a siginfo type. Now you may be wondering, what is this siginfo? Let's jump into the implementation. As you can see, we have this struct that contains a lot of information. The thing I really care is this pid type, siginfo pid. Basically, here you will have the pid of the sending process, in our case Goku. And this is important because I want to have a communication between the sending and the server. So this data is going to be filled by the sigaction function once gets triggered by the signal received. This actually I don't use, so more info. I can immediately do like that. Perfect, so here I have my signal. So let's go back to the signal implementation, SIGUSR1 handler. All right, so now let's jump into my talk.h and let's put this prototype. So void signal, take an integer. Then here I want this signal to be able to take both this prototype or this other one, like the one I'm using now. So how can I achieve this? Well, I will use a void pointer, a generic pointer. So here I put a void star, generic pointer. And as a third argument, I can use a boolean like that. That is gonna tell, hey, I want to use this function or this other one. Okay, so this boolean is gonna set explicitly that. Now, this may seem confusing, but bear with me. Later, you will link all the dots. So here we put a true. In this case, I want to use the function with this specific signature. So to use true, let's go to talk.h and let's include standard boolean as well. So include std boolean. Okay, perfect. Let's do the same for SIGUSR2. Now we have to implement the signal function. Let's create an utils file .c, include talk.h. Okay, so void signal, and we take int the actual signal, the pointer to a function, which is a generic one, and a boolean. The boolean is going to be use siginfo. I will explain why. Basically, let's read the manual for sigaction, siginfo. So info, and what do we get? As you can see, we have the two prototypes here, right? Handler with only an integer, and the other one with the siginfo and uContext, whatever. And here is the good part. Basically, the handler function should match the CA siginfo prototype if the CA siginfo bits is set in the flags, okay? So if I have the CA siginfo bit turned on, it means that I want this function prototype, otherwise this function prototype. So let's go to utils and let's understand what we need to do. So I will declare a struct sigaction equal CA. I will initialize everything to 0 like that. So now we have this sigaction. The implementation, as you saw, it is this one. We have this union, sigaction union, that contains the two prototypes of the handlers. Then we have the sigset. This sigset basically contains the actual signals that I want to be blocked while the handler is running. As you can see, it's basically an integer. We will see this later, and then we have this integer CA flags. Now here you can see the flags. The one which we want is this one, siginfo. All right, so let's start to populate this sigaction struct. I will say if use siginfo, right? What does it mean? Well, it means that you want the steroid prototype. So you need to set the flag of the sigaction flags to CA siginfo, okay? And then you do CA sigaction is equal to handler, like that. Else, well, you don't have to turn on the flag. You want the simple function. So you do CA handler is equal to handler, like that. So basically you put the handler function inside the struct sigaction. Boom, here is done. Basically our handler in our sigaction can be either ignore, sigignore, or sigdefault, if you want to ignore or leave the default behavior. On the contrary, you have to put our specific handler. In our specific case, we are gonna use an handler. Now, the CA mask is gonna basically create a mask, which is in my system just an integer, by which all the signals which are inside this set are gonna be blocked during the handler execution. So we have this set. We're going to call the function SIGEmptySet to initialize everything to 0, right? And then we're going to use the function SIGEtSet. For example, I'm going to add SIGInt or SIG segmentation false. And then we have the new set with the blocked signals. In my case, I just want to block SIGUSR1 and SIGUSR2. When my King Kai process is processing SIGUSR1, I don't want it to stop if it receives SIGUSR2 and vice versa. So I'm going to block SIGUSR1 while processing SIGUSR2 and vice versa. So I'm going to do SIGEmptySet, and as a set I'm going to say SA.mask, SA mask, and we need the address of this, like that. This is cleaning everything, initialize everything to 0, and then we say SIGAddSet. I'm going to pass the address of before and then the actual signal, which is SIGUSR1 and SIGUSR2. Okay, so SIGUSR1 and SIGUSR2. Perfect. Okay, we have done this passage. Now we actually need to kick in the machinery. So we need to call the sigaction function. Okay, so again, back to the manual. Sigaction function returns the value 0 is successful, otherwise -1. And the global variable node is set to indicate error. Perfect. So I'm gonna say if sigaction, and as an input we have the signal, this one, right? So I'm gonna write it signal. Then we need the sigaction struct, so SA, the address. And then as a third argument, I just put null, because we don't need this. Basically, this is gonna be useful if you want to know the information of the default behavior of receiving that specific signal. We don't need now. So if this is minor than 0, what do? Well, you call p error, and you put sigaction failed, and I don't know, maybe exit failure, like that. All right, this is my wrapper signal. First step, I'm gonna put the handler function. If I want the function with more data, I use this siginfo flag. On the contrary, I don't need that, and I'm gonna simply put the handler function inside its position in the struct. Then I'm gonna use this mask to block SIGUSR1 and SIGUSR2 while we are processing these signals. And then I simply call sigaction, checking for eventual mistakes. All right, this is ready. Let's go back to King Kai. Okay, now we have everything set up in King Kai. When King Kai is receiving these two signals, SIGUSR1 and 2, it's gonna trigger this handler. Let's make an experiment. For example, I call write start file number and hello and 5, like this. If I send a signal, I can do that with the kill command. So let me launch King Kai, and here I do kill SIGUSR2 to King Kai, so 7765. Boom. As you can see, King Kai is printing yellow, right? Every time the handler is gonna be triggered. You can do also 1, and here we are. This is the basic behavior. Now let's just move a little to Goku and let's start to implement this. So I will declare first of all 2 variables, pt, which is King Kai, the pid of King Kai, and char star message. I do immediately an input check if the input is different from 3 elements, so argument counter different from 3. What do? You do a file puts string and you write usage equal Goku pid and the actual message. Okay, exit failure. Okay, we have very simple input control, just based on the number of arguments. Of course, here I have to put standard error. Okay, let's move on. Now, allegedly the input is correct. Now I can do King Kai is equal to alpha to integer of argument vector in position 1, right? And the message is equal to argument vector in position 2, like that. Now I want to send char by char to King Kai. How can I do that? I can say while at message, right? You send the char, which is basically at message, and then we increase to King Kai, like that. Of course, we have to implement this function. And then at the very end, I send char, which is the null char to terminate the thing, still to King Kai. Perfect. So this is a routine to send char by char. Now let's go to implement this function, send char. I do void send char, and as an input I have a char c pt King Kai. All right. Basically the idea is straightforward. Every char is just a binary configuration. Every data in your computer is just bits, turn on and off. So for example, I have the char a, uppercase A, and I have this specific binary configuration. If I want to send this to King Kai, I can send bit by bit, right? So I can send 0, which is SIGUSR2 in my implementation. Then Goku is going to wait for King Kai processing this bit, and King Kai is going to understand that this is 0, and then it's going to give back everything is fine to Goku. And we keep going on, right? So Goku is sending bit by bit to King Kai. King Kai is going to process everything and is going to understand with time that this binary configuration is one specific letter, right? Very, very simple. This is how it works. We finished, so now King Kai has the binary, so it has the char, like that. So I have to send for every char the relative number of bits using Unix signals SIGUSR1, SIGUSR2. So I will declare an integer, I call bit, and assign the value 0. Now what do? I simply do a loop. I say while bit is minor than what? Than 8, or even better, I can use char bit, which is found, I think, in limits, probably. I will include also that. So include limits.h. Here it comes. Basically, char bit is a symbolic constant for the number of bits for 1 byte, which is most probably 8, but this makes the code more readable, right? So it's always better to use symbolic representations. All right, so I want to send bit by bit, so I need to exploit bitwise operations, okay? Bitwise operations. We said that every char is basically one specific binary configuration. For example, uppercase A is 0, 1, 0, 0, 0, 0, 0, 1. So here I can do something like that. I can say if the char ends, and what? I can do writing directly in binary, so it's going to be simpler to understand. I do 0b, 1, 0, 0, 0, 0, 0, 0, 0. So this is 1 byte. Right shift operation of bit, okay? So every time this one is going to move, right, until we reach the final position. So let's assume I have this A. Every day I'm going to say if the char. And the first bit that I'm going to send is going to be 0, right? Because 0 and 1 equals 0. Good. In the following iteration, I'm going to have this scenario. So I'm going to have 1 and 1, 1. So I'm going to send a 1. And so on. I hope you understand the point of this piece of code, right? 0, 1, 0. So every time, at every iteration, the thing is going to change. So in the case I have a 1, you're going to send SIGUSR1. This is our protocol. So you call the kill function. Now, I don't want every time to check for mistakes like that, right? If kill whatever is going to return me something. So I really like the idea of doing wrappers. I will do that with kill uppercase. The PID is going to be King Kai, right? And in the case it's 1, I'm going to send SIGUSR1 like this. Now let's go to implement in utils this kill function. So very simply I do void kill PID type PID and integer signal. And then I do here the control. I say if kill, calling the original one, PID signal is minor than 0, you do a print error, kill failed, exit failure. Like that. As you can see, a tiny wrapper. So we go back to our header and we do void kill in this fashion. Of course, with the uppercase. Okay, we are done. Go back to Goku. Now we have our kill, so we check for this condition. On the contrary, what do? Well, on the contrary, you simply kill SIGUSR2, like that. After this, you simply increase the bits, the bit position, right? So you do ++ bit. Cool. So basically, we are at this step. We are sending 1 bit. Let's go to King Kai and let's handle these signals coming from Goku. Here in King Kai, we say static char C, okay? And we say also static int bit. Why static? Well, static, if you want, simply means global private. So I want the state of these variables to be saved across callings, right? This handler is going to be called many, many times. Essentially, every char is going to spark the handler to run 8 times, right? So I want this value to be saved between states. Now, we have to actually decode the message. So decoder. Now here I don't need to initialize these 2 variables because they're static, so by default it's going to be 0. Let's go back to the decoder phase. So here I simply say if the signal received, so SIGUSR1 is equal to the signal, what do? Well, again, it's bitwise logic. I have my char C and I do or equal of what? Again, I will use 0b notation. I use 1 0 0 0 0 0 0 0. And again, right shift of bit. Very simple. These will turn on the bit in the bit position if it's 1. On the contrary, so else, to be pedantic, let's say else if and not only else. So SIGUSR2 is equal to the signal. What do? This time you use the AND operator and you basically write the same code as before. So bit. But this time we have to invert, right? We can do that with tilde, which is control 5. Okay, these are the bitwise operations that you use to turn on a bit or turn off a bit. And at the very end, you increase the bit index position like that. So this is the decoder. As you can see, we have the sending of the message bitwise, and here we have the decoding of the message, still bitwise. Perfect. Now, what if we have received the full char, namely all the bits, 8 bits? Well, in this case, if char bit is equal to bit, okay? So if bit is 8, it means that we have received the char. What do we do in this case? Well, we need to take action. First of all, I'm going to refresh the bit. So I'm going to refresh bit position. So bit is equal to 0. Then I check, is the \0, namely the last char? Because if this is the last char, the transmission is finished, right? So we're going to call the function write standard output. You can put, for example, a simple new line and 1. Now you may ask why I use write. Well, if you go to sigaction, you will see that there are a set of functions which are safe to use inside an handler, and we have the write function here. These are async, signal, save. Now you have to read the manual if you want to understand well what is going on. But long story short, we don't have the printf, but we can use the write. So you write your new line, and then you have to send a message to Goku telling, hey, everything went fine. Like, everything okay. Message received. We can do that using the signal user2. So we do send to Goku. I want to use directly the name of Goku. So what do? We here at the top put a static pid type Goku, like that. And at the very top, what do? I say Goku is equal to what? Well, here we are gonna leverage this siginfo struct, right? That contains all this data, right? Especially we're gonna use this siginfo pid that contains the pid of the sending process. So let's do that. I'm gonna do info c pid like that. Okay, so here I just send to Goku SIGUSR2, right? SIGUSR2. This is a protocol that I've implemented, like arbitrary, right? I use SIGUSR2. If Goku receives SIGUSR2, it means that everything went fine, the server has received the message, everything correct. So I simply return here. All right. On the contrary, if we don't have the last null char, well, you just write standard output, the char itself, right? So the address of char, 1 for byte. Okay, that's basically the action that my handler takes. Once we have received the char, received the char, print. What do? You just print char and tell Goku send another. Okay, so to tell Goku that we are ready and he can send King Kai ready to receive another char. We can send a signal. Again, kill Goku. This time we're gonna do SIGUSR1. Okay, I think we are ready. Okay, basically we are at this step, which King Kai is sending back. Okay, everything is fine. I wrote the char. Please send me another, like that. So to make Goku stop here, I can use a global variable here that is gonna be changed by an handler here. Let's do that. So even Goku is listening just before the while I call the signal function SIGUSR1 again. So if I receive SIGUSR1, it is an acknowledgement handler. Basically, I have King Kai telling me, hey, I received your message. Here I don't need the sophisticated prototype function, I just need the simple one. The thing is that I already have the PID of King Kai. So let's do another handler for the SIGUSR2. Basically, this is gonna be the end handler, like that. All right. Okay, acknowledgement handler. Let's do here void acknowledgement handler, and here I simply need the integer, which is the signal. Okay. What is going on here is basically turning on or off a global variable. And this global variable has this signature. I do volatile, sigatomic type, and then I call this King Kai. Now, this variable can assume two states. Let's go to the header. Let's do an enum, anonymous one, in which we have ready or busy, like that. So anonymous enums are pretty handy to create these symbolic constants pretty fast. All right, let's go back to Goku. And here in my handler, what do I want to do? I want to say global King Kai is equal to ready, right? Like that. So every time I receive SIGUSR1, which is sent here, this is the final line of code of my handler, it means that King Kai is ready to rumble. Okay? So here I do this loop and I say while King Kai is busy, so I do busy equal global King Kai, what do? Well, you loop. So you can call use leap function, I say 42. So you wait, you do what is called busy waiting. So continuously here Goku is watching this global variable, checking if something changes. Now, why volatile and sigatomic? Now, this comes from computer science programmer perspective, a marvelous book that I suggest you to read from the signal chapter. Basically, we have this problem, declaring global variables with volatile. To an optimizing compiler, it would appear that the value of a global variable never changes in the main. And thus, it would perform some optimization, namely it's going to cache in a register to satisfy every reference to the global variable. In this case, the main function would never see the updated value from the handler. So basically, volatile means, please compiler, don't do any kind of optimization. This value is going to change, even though you don't see in the code. Indeed, this value is going to change only when the process is receiving a signal. Then we have this sigatomic type. So we have C provides an integer data type, which is sigatomic type, for which reads and writes are guaranteed to be atomic. Namely, once we are reading or writing, this happens till the end. We don't have any asynchronous interruption. So this is the way by which a flag should be declared in this kind of exercise. That's what we have here, okay? All right, basically we are done with the send char function. Now we have also to create a void and handler int signal. In this case, you're just going to write in standard output something like message received or whatever. I will simply print OK and 3. And then we exit success. There you go. Okay, I think that's basically it. Okay. Now, one last thing is that here Goku is stopped. At a certain point, we have King Kai that's going to send a signal. So it's going to basically make this global variable turn to ready. So Goku can move on and it's going to send another time the char. But here I want to refresh again. I want to refresh the global variable to global King Kai is equal to busy, like that all the times. There you go. So I hope you understand what is going on. Okay, I think that's basically it. Let's try to launch. So I'm going to compile King Kai and launch. As you can see, we have King Kai that keep listening. So now we compile Goku and we launch with the PID, which is 8808. Hello. Okay, something off. Let's debug.
3 days later.
Okay, first mistake, probably here I have to initialize to busy. So I assume that the server is not ready. Second bug here, I have 1 bit less. Here it comes. That's why probably the hexadecimal notation is better. I just do 80, right? In this fashion. This is exactly the same, just we have a different aspect. Okay, let's try to compile and launch. So we'll compile and then launch. Okay, so we have King Kai server waiting to receive some messages. We'll compile also Goku. So let's launch this with the PID, which is 8981. Hello. Okay, nothing happens. Let's investigate.
Much later.
Okay, my friend, after ages, I found the solution. Basically, the problem is kind of bizarre. I found a Stack Overflow, another dude with my same problem. And basically, we have that cpid sets itself to 0 after a few calls of the same function. So with this little piece of code, I'm telling, hey, make sure that cpid is not 0, right? And here being static, all the times I have 1 PID, okay? So the PID of Goku. Even though here I have 0, I still have the previous one, given that this is static. Okay, let's try to launch and let's see what we get. So I compile again Goku and I compile King Kai as well. I just launch King Kai like that. Now I launch Goku. PID is going to be 9394. The message is going to be hello. Okay, as you can see, it worked. and I have the OK, send me back. Now maybe I can change here. I can put OK and the new line, 4 bytes. Let's recompile. Hello, hello, hello. As you can see, I have the server that keeps listening to me. Okay, this is a Python little script that is sending a lot of messages coming from lorem, whatever. And interleaved, I have also some emojis, which are not ASCII code, but at the end of the day, they are just bits. So we actually don't care. I just send this. And as you can see, I have my King Kai that is printing all these things coming from Goku. It's moving pretty fast. Allegedly, nothing is stopping. Now we wait a little. If we manage to reach the end of this, everything seems to work. I don't have any stopping. Okay, maybe let's do this not that long, otherwise I'm not gonna finish anymore. So here I just do not 300 but 30. Okay, let's launch again King Kai. We change the PID again, 9451. We launch. Okay, everything seems to work correctly. Boom. Okay, now let's do this Python script, only 3, and we do a while loop. And I'm gonna copy this boy and do a while loop. So I do while true, keep calling, and okay. It seems like the communication between King Kai and Goku is going well. King Kai is able to receive all the messages pretty fast, and nothing seems to break. Okay, this is a very simple program, only handling 2 processes, not taking care of many corner cases. And basically, let me try one other thing. As the code is written, I think that I can also remove this 2. I don't need to block, because by the way the thing is set up, probably I don't need that. Let me try again. So King Kai, okay, let's try to launch again. Let's launch Goku, 1-1. Okay, let's try to launch, and it worked as well. So I don't actually need to block SIGUSR1 and SIGUSR2, because by the way the code is written, it is not necessary. Alright, for this little project, that's it.